Okay, let's make sure, can you get that answer on? You got to be in degree mode. Hit the buttons on your calculator. Tangent of 34.7 should be 0.6924. See if you can get that on that. Yeah. So let me know, or check with those around you. You got to get your calculator in degree mode. Yeah, the mode can be kind of tricky. It's different on every calculator. Is that a D? That's a D, isn't it? Yeah. Okay. You can't either, huh? I think it's a D. Did you try just hitting tangent 34.7? I think you're in the right mode. But yeah, I think it's good. Exactly. Yes, perfect. Yeah, so give it a try. Hit tangent 34.7. See if that's coming out for you. And we'll just round. They just want us to round to 4 places, so I'll move on. Hopefully, y'all getting that okay?
Okay, yeah. So you can...
Yeah, no, help those around you, please. That's great. All right. I'll go on to... So switch into Radian mode now and see if you can do cosine. And you got to use the pi button also. First off, make sure you're in Radian mode, however that is on your particular calculator. They're all a little different. Secondly, if you have the nice kind of calculators, I mentioned already, you don't have to get this one at all. But one that is, I would say HP, not HP, Casio, natural display. That is a very nice one. It's very easy to use. Things look natural. That's the name. It's true. Anyway, but it's okay if you have a different one. You don't have to buy that one. But if you have one of them that puts everything on the same line, like flat like that, the older kind, instead of the ones that make it look like a fraction. That's like what the Casio Natural Display and a couple other ones do. They're real nice and user friendly. But if you have one that does it all in one line like this, and if you type that in just like that, you got to put parentheses around that. Otherwise, it'll only, if you just type it in without parentheses, and some of them automatically do parentheses, I think, huh? But if you just type it in like that without parentheses, you know what's wrong with that? It'll only do the cosine of 15 pi, and then it'll put the 16 down here. That's different. You understand? Cosine's a function like a toaster, and you're plugging in the bread, so to speak. The question is, what's plugged in, the whole 5 pi over 16 is supposed to be plugged in, and the way you tell your calculator that is you put it in parentheses. If you write it without parentheses, cosine 5 pi divided by 16, no parentheses, it really means that. In other words, the 16 is not plugged into the toaster. The 16 is down below. Do you see that? The calculator doesn't know. It's stupid. It doesn't know what you're plugging in. You have to tell it somehow. And if you just do it like this with no parentheses, it'll assume only the thing after the cosine is the plug-in, and everything else is outside of the toaster. Does that make sense? So parentheses. Oh, but if you have the Casio Natural Display or ones like it, then you don't have to worry about that because it looks just like it is. You don't have to think about parentheses. It knows right away. It's kind of nice that way. But anyway, it's fine whatever one you have. Y'all getting that okay? So if you have trouble with that, raise your hand. And I'm going to move on. I got a bunch of other questions to go through. But raise your hand even. Wendy can bounce around. I got to get moving. But Wendy can bounce around. And grab me after class. I'm glad to help. All right, so they want me to find side A. This is question number 13. They want me to find side A over here in that triangle, given that information. I hope you're all getting on Math Excel okay. If you have any troubles, there's a support phone number. I got a couple emails from different people having trouble. I'm terrible with tech. You're probably better than me. Just call them. Their support line is up there. In fact, remember Sohcahtoa that we talked about on Wednesday? You couldn't think about anything else all weekend, right? Sohcahtoa, right? Maybe not. All right. Maybe you have other things in your life than my math class. But anyway, so if this is the angle, the 38, okay, this is the hypotenuse, right? Because that's the longest side, the side across from the right angle. And then the other two sides are called opposite and adjacent. Adjacent means next to you, like your neighbor lives adjacent to you. So the B is the adjacent, huh? And this is the opposite from the 38. If we were using the angle up here, then that would switch to who's opposite and who's adjacent. Anyway, we're doing the 38, so you tell me, I want a trig relationship, that involves the A, because they're telling me to find that. That's what, you can't see it anymore, but that's what they said. Find the little a. And I know that the B is 400. So what trig relationship involves these two? Yeah, because that's opposite, adjacent, toa. Tangent, huh? Right, remember sine is opposite hypotenuse, cosine is opposite, adjacent hypotenuse, tangent's opposite adjacent. So tangent, opposite over adjacent. So that means tangent of 38 degrees, this angle, is the opposite from that, which the opposite is little a, over the adjacent from that. The adjacent is the 400. Does that make sense how I came up with that? Now we can use that to solve for the little a. How do I do it? How do I find the little a? What do you do when you have a fraction on one side and a non-fraction, whole number, whole expression, whatever, whole number, fraction on the other? What do you got to do? Make them both look like fractions, put that over 1, they both look like fractions, and cross multiply. Have you seen that before? I can't remember if we did that last time or not. Cross multiply, diagonal, diagonal. So then you get 400 tangent 38 is 1 times a, which is just a, huh? We good so far? This is what you do when you have a fraction on one side, whole number on the other. Put it over 1, make it look like a fraction, cross multiply. And then, and that's it, huh? This is a. And then just hit the buttons on your calculator. Is it 313? I think I saw the answer, and you did too, when I started the problem. Let me double check though. 400 tangent 38. Yeah, it rounds to 3. It's 312.5. They said round to the nearest whole number, 313. Y'all able to get that on your camera? And so, how do you know what mode you're supposed to be in, degree or radian? Well, see, this is degrees, yeah. So make sure you're in degree mode, which we were just in radian, huh? You gotta change back. You always got to be changing, making sure you're in the right mode there. On that, not good. Questions I can answer. I'm gonna move on if you're okay. Question?
How do you go into radian mode on the Casio natural display?
On the Casio natural display. I don't know.
You're going to go shift mode.
Shift mode?
Setup, and then number 4.
Shift mode and then what?
Number 4.
Okay, thank you.
Yeah. So I'm given the number 6776337. All right. We better move on. Okay, try that one. So they want me to find, I'll circle it for you. They want me to find C on this problem. I want you to find C. So think about Sohcahtoa. I'm going to write it down again. Sohcahtoa. And which trig relationship you want to use. So the angle's here, 35. Write down, if you need to, if it helps you, write down adjacent, opposite, hypotenuse, you know, which sides are which sides. We good? So this is the hypotenuse. This is the adjacent side to the 35. From his perspective, this is the side next to him. This is the opposite. So how do you know which ones you want to do? Well, the C is the one they want you to find, and the 19 is the one I know. So you take the one you know and the one they want. That is opposite and hypotenuse. So which, on the Sohcahtoa, which of those has opposite and hypotenuse? Sine, huh? So the sine is opposite over hypotenuse. So the sine of 35, that's a little scribbly, of 35 degrees is opposite 19 over hypotenuse C, huh? Is that good? So we got to there. Now, can you solve it from there? Put this over 1, right? Put this over 1, diagonal, diagonal. Can you take it from there? So I get C, whoops, come on. C times the sine of 35 degrees is 1 times 19. And now what do I need to do to finish? Right, everybody get it? I just cross multiplied. The C is in front of the sine. Now C is, we're trying to get C alone. So I have one more step this time, don't I? How do I get C? C is wants to be alone, and yet he's next to this sine 35. So what do I do to get him alone? Divide by that sine 35. Got to do the same thing to both sides to keep the balance. Cancels out. C equals. Hit the buttons on your calculator. Make sure you're in degree mode. That's a degree angle. Oops, I forgot the little degree symbol. There we go. Sine of 35. I'm getting 33.125. I don't know how far they want me to round. What I didn't notice.
The nearest whole number.
Nearest whole number, so 33. Good? Is that coming out okay? Make sure you bring your calculators to class. Yeah.
Oh, I was just trying to figure out how to get back out of Radian Mode.
Oh, okay. Yeah, Wendy, if Wendy could. Thanks, Wendy. Good. Any other questions on that one? All is well? All right. Okay, so got the answer already there for you. So they're telling me tangent of theta is 6.6378. Tangent of theta. And they want me, is everybody tracking with me so hard? Let me just bring it down here where I can have a little more room. 6.6378. There we go. Okay. And they're saying, look what they want. They're saying, hey, give us theta. And I've already found the answer. Let's see how I found it. They're saying, find theta for me. Find theta. Get theta alone. So what that means is theta is saying, I want to be alone. Right? I want to be alone. Get rid of this tangent so that theta can be alone. That's what they're asking me for, huh? Okay, so how do I get rid of that tangent? I've got a good idea. Let's divide both sides by tangent. Theta's alone. Go ahead and try that on your calculator. And so go ahead and hit the buttons. Tell me what you get. Yeah, look. Tangent of what? The calculator's like, tangent of what? Tangent alone is not a thing. Do you see that that's wacko? But everybody does it. I'm sure I did it when I was first a trig student. So I want to do it wrong and say, don't do that. Just to really sink it deep in your minds, I'm hoping. Does everybody see that that's crazy? There's no such thing as a tangent or sine or cosine or any of the trig functions without an angle. They're meaningless without an angle. You've got to have tangent of 30 degrees or tangent of 60 degrees or tangent of something. There's no such thing as tangent alone without an angle. I can't divide by tangent. That's not the right thing to, but it looks so good, doesn't it? That's why I'm sure I did it and everybody does it, but it's not right. Now why? Why isn't that right? Why can't I just divide by the tangent like that? You know, because if I had a number there, if it was like 3 times theta is 6.6378, I would divide by the 3, right? So why don't I do that with tangent?
It's not a value.
It's not multiplication. So this is worth, time is precious to us, but this is worth 30 seconds of sync time. Because this will save you tons of errors throughout this class, pre-calc, and calc. If you can really sync, this is a mistake repeatedly made with all kinds of functions. So that's why I do the toaster talk. This is not tangent times theta. Although it visually looks like that, huh? It's not multiplication. You might say, yeah, but I've seen it with parentheses like that. It's times. Yeah, you're right. It does have parentheses most of the time. But it's not times. It's plugged into the tangent. Like plugging into a toaster. right? That's why I made up the toaster talk, because I saw this mistake being made by students for tons of times when I was first teaching. So what's really important for you to get, I know we don't get everything yet, and we'll get it as we go on in time, but that is not multiplication. Same thing for sine, because none of the trig functions are not multiplying. That doesn't mean tangent times theta. It means tangent of theta. So you're plugging the theta into the tangent machine, like putting bread into the toaster. The bread is not multiplied by the toaster. It's plugged into the slot, and the toaster does something to it. That's what I mean by toaster. What do you do with bread? What does the toaster do? Toaster is a function. You put stuff in, you put in frozen waffles, turns it into toasted waffles. Put in bread, turns it into toast. That's what a function does. It takes stuff in, changes it, spits it out different, right? Well, that's what tangent, sine, cosine, that's what all the trig functions are. They're functions, which means you put stuff in, it does something to it, and spits it out different. Not multiplication. It doesn't mean tangent times theta. It means theta plugged into the tangent machine. And it does something to it and spits. Okay, so with all that, you go, okay, that's not multiplication, even though it looks like it, huh? It's not. And you really want to remember long term. That's something that'll benefit you long term to know. That's not multiplication. Okay, so with all that, it's really important to know what not to do, because everybody's tempted to do that. That's not what we do. Well, then what in the world do? We got to get rid of that tangent. If we can't divide by it, what do? How do we get that? Okay, it's a function, Mr. Aaron, it's a function. How do we get rid of that function then? So now what's the right way? Does anybody know? Other than Wendy? I know Wendy knows. Yeah.
Inverse tangent?
Inverse tangent. That's what inverse functions are all about. I don't know if you've done much inverse functions. There's a whole bunch of that in pre-calc. We'll do a bit of it in here. You do inverse tangent exactly right. Inverse tangent is the opposite of regular tangent, like an inverse toaster. That's weird, huh? What would an inverse toaster do? Yeah, put in toast, turns it back into bread. Just does the opposite, right? So it just does the opposite. So you get the idea. That's what an inverse function does, is it does the opposite. So you do that and it'll cancel it out, because it's the opposite. But whatever you do to one side, you have no choice but to do the same thing to the other, because you're keeping the balance, right? If two things are equal, treat them the same, they'll still be equal, right? So I treated them the same. I did tangent inverse on both sides. That's what you do. That's correct now. That'll get rid of the toaster. You put an inverse toaster. You put that bread back into the inverse toaster, the toast, turns it back into bread. So, okay, but on the other side, its tangent inverse is 6.6378. And you have now we hit the buttons on your calculator. You have an inverse tangent button on your calculator. So now grab the inverse tangent button. It's usually right above tangent. You usually hit second and tangent, get inverse tangent. 6, and make sure you're, they want a degree answer, so make sure you're in degree mode. I'm getting, that 81 answer, 81.43 degrees, rounds to 81. Y'all able to get that? So that's how we get rid of a trig function. Not by dividing, because it's not multiplication, by inverse trig function, inverse whatever, sine, cosine, tangent. So I did inverse tangent on both sides. Where did it go on the left side? Well, it canceled, because there was both tangent inverse and tangent, right? They canceled. That's why I did it. I wanted to get theta alone. But on the other side, it stayed, because there was nothing to cancel it. You'll see? And then we had to do it on our calculator. That good? All right. Okay. 1 plus sine squared of 80 plus sine squared of 10. I already have the answer. There's 2. Why in the world is it 2? It says do not use a calculator. So how can we do this? So on the test, I'll have two parts. I think I mentioned already, calculator, non-calculator. When's our first test? It's next week on Thursday, huh? Wednesday. We don't meet on Thursday. Next Wednesday. We do next Thursday. So why is that true? I don't even remember right now, to tell you the truth. That's concerning, huh? There's some good reason, I'm sure. Oh, yeah, I remember now. Okay, so remember what we learned about cofunctions last time? Does anybody remember? I know it's been 5 days. Remember, half of them are called like cosine, cosecant, cotangent. What does that mean? What's the co, and what's that have to do with anything? I remember I did say that. I do remember talking to you about that. And you never forget anything I say, right? Complementary. And what does that mean at the angles? That's right. The co means complementary. Add up to 90. So remember with the like cosine of whatever, 30 degrees is regular sine of 60, meaning total 90, because that's complementary. Right. Complementary means two angles, total 90. So all you got to remember is if you have like a trig function and his and the angles total 90, they're going to be equal. So for example, you could have cotangent of whatever, 50. That would be equal to regular tangent of 40. Do you remember that? That's what the thing is. So a function it is if the two angles total 90, then they're equal. And you can switch them out. Well, okay. See what they're doing with the 80 and the 10?
That equals 90.
That equals 90.
One whole.
So look at this for a second. This, and don't worry about the squared. That's just squared. That's going to be cosine squared of what? 80. Right? Everybody see, I'm changing. I'm leaving these as they are. And you can change either one. Basically, you want to change one of these to a cosine. It doesn't matter which one. So whenever you go from tangent to cotangent, or sine to cosine, or secant to cosecant, if you do the other angle so they total 90, they're going to be okay to do that. They're equal. You can replace it. They're the same. Everybody tracking with me on this? So anywhere I see sine of 10, I'm free to replace it with cosine of 80. It's the same.
You just replace one of them?
Yeah. Now, why? Because I know something else, where I'm going somewhere. Yeah, you're right. Because could I replace both of them? I totally could. But I have a certain goal. The other goal I'm remembering is that sine squared of any angle plus cosine squared, this is what I want. I want one of each, equals, anybody remember? 1. That's the other special formula. These angles must be the same, though. Same theta, right? Whenever they write a formula and they use the same letter, they have to be the same value. So they're saying if you have sine squared of anything plus cosine squared of that same thing, it's just 1. So that's why I'm looking at this sine and this other sine and going, oh, if I make one of them a cosine using the 90-degree coangle thing, then I'll have 1 plus sine squared plus cosine squared. And then the angles are the same because I did the thing. And so what do these two right here make? 1. So it's 1 plus 1. It is 2. Did you track with all that? So the whole deal was I wanted to get sine squared plus cosine squared of the very same angle, because as soon as I see that, all of that is just 1, and then the other one that's already there, and 1 is 2. And how did I get that? Well, because you go from sine to cosine, if you change the angle so it totals 90, you can do that. That's always going to be the same. So we use those two facts to do that. It's kind of tricky of them. Tricky question. Good on that? So this is number 18. Yeah, just use a calculator for now. We're about where we won't. But yeah, can you do this one on your calculator? So they're saying they've got this trig function. It's 2 cosine. So it's f of theta to toaster, right? Plug stuff in, changes it, spits something out. And here's what you plug in. Here's the toaster you're plugging into. And they're saying, hey, put pi over 6 in there and there. How do I know that? Well, because you see the pi over 6 is after the f, which means it's right here, which means it's taken the place of theta. So I put it in the theta spot, put it in the theta spot. What do I get? 2 cosine pi over 6 minus sine of 2 times pi over 6. You with me? And then just hit the buttons on your calculator. Oh, no, they're right. They want an exact answer. I'm going to have to show you. Yeah. Anyway, but are we good to there? We good to there so far? Everybody see what I did so far? They just said, find, here's their actual question, find f of, that doesn't mean multiplication. Notice I'm not saying f times. That's not times. That's a toaster. We're plugging into functions or toasters. You're plugging into the toaster. F of. Plug pi over 6 into the F machine. What's the F machine? Here's the F machine. Anything you plug into it goes into the cosine slot and the sine slot. So I put the pi over 6 there and the pi over 6 there. That's the F machine. I plugged pi over 6 into the F machine. Now I got to work these parts out. How do we do that? Well, yeah, because we're going to have to use, going to have to find the exact values. I didn't realize that was at the end of this section. Okay, so good. Well, we're going into it for the next section anyway, so let's go ahead and go there. So to finish this problem now, let's halt right here. I'm going to go aside, and I'm going to do like a long thing. Now, I'm going to come back, and I'm going to finish. So the long thing is basically what we're going to use like for the rest of the entire course. So this will be our first time. So are you feeling alert this morning? Well rested? And because this is super important. So we're going to talk about how do you find, I thought we could put it off to the next section, but how do you find cosine of pi over 6 without using your calculator? I have to not use my calculator because what? Because they're giving me an exact answer, not a decimal. So I'm going to have to show you how to do it without a calculator. So how do you do it? How do you do that without a calculator? Here's what you do. So I'm going to show, I don't know if you've learned how to do this before. I'm going to show the unit circle approach. Here we go. So I'm going to show a way of finding sines and cosines, really all the trig functions, on a unit circle, memorizing, or you get a 3x5 card on the exam, but it's true that we will memorize certain values or put them on a 3x5 card. 3 values in every quadrant. All right, so my circle looks kind of flat, but you get the idea. So I'm putting a dot right in the middle there, and then 1 on each side. Every quadrant, right in the middle, 1 on each side. Right in the middle, 1 on each side. Right in the middle, 1 on each side. So 3 dots in every quadrant. This is how we do trigonometry. We memorize these spots, know these cold, and everything else, we just use our calculator. That's how everybody does trig, on through calculus and beyond. All right, so what are these angles? Remember, where do we start? Where's 0 degrees? Straight right, huh? I don't know why they didn't make it straight up, but they didn't. They just made 0 straight right, okay? What is straight up, by the way?
90.
This is 90 degrees, huh? Remember that? Straight up's 90. All the way around is 360. This is 180 over here. This is 270 right here. And all the way around is 360. You know all that. Anyway, okay. So what's the one halfway in the middle? Between 0 and 90, halfway. This dot right in the middle between 0 and 90?
45.
That's 45 degrees because it's halfway to 90, huh? 45. Now the other two, there's no way to exactly know them. I'll just tell you. This is 1/3 of the way to 90, so that's 30. This one's 2/3 of the way, so what's that? 60. That's 6/9, 2/3. 2/3 of the way. Okay. That's going to be, well, let me just leave it at that for now. And now, we're going to find the sine and the cosine from the height, from the horizontal position, and the x and the y. Let me just say it that way. From the x and the y value. In other words, this dot has an x coordinate and a y coordinate, like meaning how far over it is from the origin, how far over it is, and how far up it is. It's x and it's y. How far over, how far up. How far over is always cosine, and how far up is always sine. That's how we get cosine and sine off the unit circle. Now, hold on a second. Doesn't it look like I'm just kind of making this up? I mean, really, let's just be real for a second. Doesn't it look like I'm just really making this up right now? Like it's on a circle and it's, cosine is over and sine is up. I mean, really? What is cosine and sine? I mean, what are they? Like, I mean, in the real world. Are they anything in the real world? Can you show me a cosine? I mean, why are we doing this? Right? You guys want to get a bachelor's degree, right? And you get a good job. That's why we're doing this. But I know, I don't actually mean that. I mean, why do people do cosines and sines in the real world? Why do engineers and scientists use sines and cosine? What is this? Anybody know?
Define coordinates?
It can involve coordinates, yeah. Let me say it simply this way. I would have, by the way, not known the answer. Somebody had grabbed me when I was taking all these classes in junior college like y'all, said, what is sine and cosine? You know, even after I learned how to do them, I would have said, I have no idea. I could do them, but I don't even know what in the world they are. Here's what they are. So let me just, as we dive in real quick, anything that goes up and down in the real world, sines and cosines are super useful for representing them. So in other words, real practical, right in the wall, alternating current, the plugs, right? Well, not that plug, but the AC, that's called AC, 120 AC coming out of that current. What does AC stand for? Alternating current. It's a sine wave. I don't know if you know that. But, you know, the power coming out of alternating current is an up and a down. The power goes up and down, actually, is what it does. Unlike a battery, which has direct current, DC, it's straight and flat. Anyway, there's one thing. The oceans, right? The tide goes out and in, out and in. All kinds of motors, mechanical engineering, right? The pistons, they go up and down as they fire, right? While the gas is being burned. And on you go. There's a million things in the real world that cycle. All kinds of things cycle. They go up and down and up and down and up and down. And we need math formulas to predict when they're going to be up or when they're going to be down or how fast they're going or, you know, whatever the million things we're trying to do in the real world with these things that cycle. And so they made up, and they did. You hear me say that. This is made up. It's totally made up. But they made it up to fit a real-life purpose. All of math is made up, by the way. I don't know if you know that. All of math is made up. There's no such thing as a sine. You can't grab it with your hand or a cosine or a tangent. It's all made up to help you deal with things that are real. So sines and cosines, they looked around, engineers and people like that, said, look, we got all these things in real life that are going up and down, cyclical things. We need some math thing that goes up and down, so we can use that to do what we need to do. That's sine and cosine. All right, so with that said, what I'm doing right now is totally made up, but it's made up because as you go around this circle, the dot is going to go up and down, negative and zero, positive, negative, up and down. That's all it's going to do. That's all we're doing here, is we're tracking a little dot that goes up and down, because all kinds of things in the real world are cyclical. So, all right, so here we go. With that in mind, that's exactly what I'm doing. So the x-coordinate is always cosine. They just made that up. And the y-coordinate is always sine. Made it up. Because they needed something. They said, let's call it x. Let's call it the x cosine. They could have switched it up. They totally could have. They just made this up. So they said, all right, the x value is cosine, the y value is sine. What are we going to do with it? So, well, I need to know how far over is it to the 30-degree dot? And how far up is it to the 30-degree dot? Well, it's actually very simple. There's just 3 numbers to memorize. Let me write them somewhere. I'll write them right in here. There's root 1, root 2, root 3. Make it really easy to memorize. All over 2. Root 1, 2, 3, all over 2. This is the small, the medium, and the large. Small, medium, and large. Put that up here for you too. Small, medium, and large. Root 1, root 2, root 3, all over 2. This is what we do. We just memorize those. That's all you need is those 3. Small is like ordering a soda. Small, medium, and large. Root 1, 2, 3. And by the way, to simplify, what is the square root of 1? That one can be simplified, huh? That's just 1. So I'm just going to write. I showed the root at first, though, just so you can see the clear pattern. Math is patterns. Root 1, 2, 3. The root of 2 and the root of 3, you can't simplify those. So they just stay that way. But the root of 1, that's just plain 1, right? Okay, so a half, root 2 over 2 and root 3 over 2. Those are the 3 values, root 1, 2, 3 over 2, that we use for all these dots around the circle. They're all going to be some combination of those 3 numbers. It's always just those 3 numbers. That's all we remember. Everything else, we use our calculator. So, all right, so how do you know what's what then? Well, just look at the dot we're at now for 30, and all you got to think about is, hey, is the x, let's start with the x. How far over is that? Well, I don't exactly know, but it looks like a lot. It's the large. Right? Do you see that? And the y, how far up is the y? It doesn't look like it's little, small. So this is over the large, up the small. The large, the small. So the x is over root 3 over 2. The y is up the small. That's all you got to use. Just ask yourself, right? That's over a lot, isn't it? That's only up a little. Over the large, x is root 3 over 2. Up a little, it's only up the small amount. The y is the small amount. And that's a half, the small. So that means then that 30 degrees, the cosine is root 3 over 2. And the sine of 30 degrees is a half. Let's go to the 60-degree angle. What if we're here? Let's find his x and y. How far over, how far up? Well, it's only over a little bit, up a lot, huh? Yeah, so this is small. This is large. Whereas this was large. Small that way, huh? Everybody see what I'm saying there? Now, the ones in the middle, those will be medium, medium. They go together. We'll do that in a second. But I just want to say that right now to put in your mind. All the medium spots, like this spot, this spot, this spot, all the ones in the middles, they always are medium. He just goes with himself. The medium goes with the medium. He never mixes with the small or large. And the small and large always go together. So all these points, all the middle ones are medium, medium. And all the other ones are small with large, one way or the other. So the 60 degree is over a small amount, up a large amount. It's over a half. Right? The smallest one, root 1, 2, 3, so the smallest is root 1, up a large, up root 3 over 2. So this is over a half, up root 3 over 2, huh? For this dot right here. It's over a little bit, up a lot. And what is that? That's cosine for the x by common agreement. They just made it that way. And the sine is the y. They just needed something that went up and down, cyclical. So the cosine of 60 degrees is a half. The sine of 60 degrees is root 3 over 2. Makes sense? Now, how about the middle? Let's do the middle. Right here. That's over a medium amount, up a medium amount, isn't it? See, that's medium, medium. We'll kind of get rid of some of this other stuff here. It's getting kind of messy. So this is over, the middles are always, it's over medium, so root 2 over 2. Up a medium, root 2 over 2. So this one is root 2 over 2, root 2 over 2. Like I said, the medium always goes with the medium. Mediums with mediums. They never mix with the large or small. So that's cosine for x, sine for y by common agreement. They just made it up that way. You got to remember that, though, because it's kind of reversed the natural. Like I'm used to thinking of sine first and then cosine. But be careful, the cosine comes first. The cosine's the x, the sine is the y. Which they would have made it up the other way, would have been more natural. But whatever. They made the cosine the x and the sine the y. So therefore, the cosine of 45 degrees is root 2 over 2. So is the sine. Sine of 45 is also root 2 over 2. Now, where those numbers are coming from is triangles. Maybe I can show that another time. But this is on the unit circle, which means it's circle radius 1. Anyway, we'll get to that later. I don't want to give you too many details. So, all right. So what if we go into the other quadrants? It's the exact same thing, except you have some negatives. Let me do one. How about if we go like to this dot right here? Oops, I thought I changed to a different color. There, this dot right here. So, okay, how do you get to that dot? You go back, that's negative, huh? And up, that's positive. So back a small amount, huh? I only went back a little bit to get to the, what is it? Oh, by the way, what is this angle? The ones that are next to the straight up points are always off of them by 30 degrees. In other words, there's 0, so that's 30. So if this is 90, this must be 120. If this is 180, this dot here must be 150. See what I'm saying? The ones right off the straight up and down or straight sideways, they're always 30 off like that. So 180, 150, 90, 120. The ones in the middle, they're always 45 from there, huh? 45, 90 plus 45, it's 135? 135. Track them. They're always in the middle, right? So they're 40 because the whole thing's 90. One quadrant is 90, so add 45. So anyway, let's go back to the 120. So looking at the 120 for a minute, how are we going to get that 120? Well, it's back a small, back a half, up a large, up root 3 over 2. Isn't it? Back a little bit, that's why it's negative, huh? Back a little bit, up a lot. So this one is back a half, his x-coordinate. Whoops. Kind of running out of room up there. Back a half, up root 3 over 2. And that's what? Cosine, sine, by common agreement. So the sine of 120, root 3 over 2. The cosine of 120, negative a half. Is that making sense? If you can do this, you can do all the trig functions. Because this will give you all the sines and cosines anywhere on the circle. All the sines and cosines anywhere in the circle. Let me show you what I mean. Let's just do one. How about we say, really? Okay, like how about right here? What's that spot? First off, what is that angle? 270, add 45, because he's in the middle, right? Add 45. That'd be 315. You can do that in your calculator. 270 plus 45 is 315. That's 315 degrees. Okay. And what if I want the sine or the cosine of 315? Well, that's over and down. What is it? Small, medium, or large? The middles are medium, medium. That's over root 2 over 2. Over, right, positive. Now, right is positive, left is negative. Up is positive, down is negative, like natural. So, positive, over, and down, root 2 over 2. So, the x is positive root 2 over 2. The y is down root 2 over 2. This is the cosine. This is the sine. By common agreement, the cosine is x, sine is y. The reverse of what you would naturally do. So the cosine of 315, root 2 over 2. Sine of 315, negative root 2 over 2, etc. We can get any of the angles using this. It's as simple as that. It's just small, medium, large. How about like the dots that are straight up and down? Like how about 180? Like he's straight on the axis. It's the same thing, except you don't need to use the small, medium, large, because that one's just straight back, isn't it? Now, this is the unit circle. Unit. What does unit mean? It means 1. This is the 1 circle, which means it's radius 1. This is a circle it's 1 straight up, 1 down, back 1, all the way to here is right 1. The radius of this circle is 1. It's the unit circle, the 1 circle. Okay, so if you know that, if you know the radius is 1, what are the coordinates? I mean, like the x, y coordinates of that spot? Back 1, up 0, huh? Isn't that dot, like x, y, isn't that back 1, up 0? That dot, x, y. Okay, and so the cosine, by common agreement, the x is the cosine, the y is the sine. So what's the cosine of 180? Negative 1. What's the sine of 180? 0. Does everybody see that? Let's try this one real quick. Let's do 270. Let me give you a second. I'm kind of whipping along here. Let me slow down and give you a second. So write the coordinates, like, meaning from the origin. From the origin. Don't say it out loud. Give everybody a chance to think about it. From the origin, how far over and how far up or down to get to that dot. Remember, this is 1, right? It's a unit circle, radius 1 circle. So how far? Write the x, y, the x, y coordinates here for how far over, how far up or down for that dot. And then cosine is the x, sine is the y by common agreement. So for that dot, how far over and how far up or down? What are the coordinates? X, y?
0, -1.
Over 0, down 1. Everybody good with that? That dot is over 0, down 1. Boom. Right? So this is the cosine. This is the sine of 270 by common agreement. So there we go. You can get any of those dots now. Just by knowing the small, medium, large, and then the zeros and ones for the straight up and down, straight sideways points. That's what we do. Now, any angle other than that, like how do we do 29 degrees just before 30? We use our calculator. And this is valuable. You might wonder, why don't we just do our calculator for everything? Well, it's helpful to know, to memorize these ones or know how to find them without a calculator. Because at least if you're going to calculus. If you're going the way of calculus, I don't know what your plans are, if this is it for you or you're going on. But if you're going the way of calculus, you do what's called limits. Things are moving, and so you want it. You want to know more than just calculator answers, because you have to feel it. You have to feel it. Sounds like touchy-feely, but you do. But in calculus, you got to really know what the trig functions are doing, because they start moving them on you. Calculus is all about motion. So things will be moving. You'll take a limit, it's called, as a dot moves somewhere. So if all you know is exact values from a calculator, you don't really understand that, oh, it's a height, and it's closing down to 0. Anyway, that's why it's done this way. So, all right. So with all that said and done, let me show you. I put on the website, on the Math Excel site, a unit circle for you already there. I don't know if you noticed it. Oh, no, anything you want. Anything, so you can copy that. That'd be nice, huh? Just copy this, shrink it, put it on your card. Absolutely.
sides or?
Both sides.
Okay.
Both sides. 3x5 card, both sides, anything you want. Yeah, I would copy, shrink, and put that thing on there if you know how to do all that. Yeah, on that would be good. All right, let's finish the problem. What is the cosine of, pi over 6, I forgot, the radians, we got to convert that to degrees. Pi over 6, pi is 180, right? Remember that's 180? So that's cosine of 180 over 6 minus sine of 2 times 180 over 6. So that's cosine of 30 degrees, isn't it? Minus sine, and that's 2 times 30 degrees. So that's 2 cosine 30 minus sine 60. Everybody good so far? I changed it from radians. You don't have to. By the way, I put radians on that unit circle picture. You could just do it that way. So it's real convenient that way too. But anyway, 180, I just put, remember pi is 180. Remember that's the bridge between the two worlds? Radian world and degree world. Pi and 180 are the same thing. So whenever I see pi, I pop a 180 in its place. They're the same. 180 divided by 18 divided by 6 is 30. So, and then this one's 2 times 30, so 60. So now go to your unit circle, find the cosine of 30 and the sine of 60. Let's do that. So we're still trying to finish up problem number 18 here. So problem 18 is cosine of 30, right? What is it? Cosine of, 2 cosine 30 minus sine 60. 2 cosine 30 minus sine 60. Okay, so I'm going to draw my own little unit circle here. Could use the official one, but I think it's a good habit to get into, to just draw it yourself. You'll get it more solid than just looking at that thing. If you can discipline yourself that way. So let's find 30 degrees. So this is 0. So 30 is right here, isn't it? That's 30 degrees there. 60 is up here. 45 is the middle. Remember, they're 30 degrees off. This is 90 straight up, so they're 30 degrees off. That, okay, so think about 30 for a minute. Over a lot, right? Over a lot, over root 3, a lot, up only a little. Whereas this one's only over a little, up a lot, isn't it? See that? Okay, this is cosine, sine. This is cosine, sine by common agreement. It's out of order. Cosine comes first, then sine. So what do they want? Cosine 30? Bless you. Cosine 30, what is it? There's cosine of the 30, so this is 2 times root 3 over 2 minus sine of 60. What's sine of 60? 60 sine is also root 3 over 2. We good so far? Bring this down. What am I going to do? I could multiply, I could do a lot of things. Let me make this super easy for you. What's 2x minus 1x? 1x, or just x, right? So what's 2 root 3's over 2 minus understood 1 root 3 over 2? 1 root 3 over 2. In other words, root 3 over 2. That's easier than anything else you could do. Everybody track with that? You have 2 monkeys minus 1 monkey, it's just a monkey, right? If you have 2 root 3's over 2 minus 1 more, it's just one of those, isn't it? So there it is. There's the answer. Everybody good on that? That whole unit. We're going to go crazy now with that whole unit circle thing and do a ton of it. Just to, it's not just, you'll have a lot more practice. It's not just that. We'll practice it a ton. All right.